Now we can see the physical properties of aldehydes and ketones, right? So the first member of aldehyde, methanol, that is HCHO, that is a gas at room temperature, and the second member ethanol is a volatile liquid, that is acetaldehyde is a volatile liquid, so that easily evaporates, and the rest of the liquids are solid or liquid at RT, at room temperature. Right. So the first member is a gas, the second member is a liquid. So that is what we can remember there. As per the BP, the boiling points of aldehydes or ketones are higher than the corresponding hydrocarbons and ethers of comparable molecular mass. This is an important question. They will give two things, that is one aldehyde, one ketone, and one ether, or one aldehyde or one ether, and they ask you to compare the boiling points and justify. So, for example, if they are giving two compounds, that is one is an diethyl ether and another one is an ethanol, or equal weight, almost equal molecular mass. So why that ether is having lower boiling point than the corresponding aldehyde? That's a question. So the reason for that question is weak molecular associations in aldehydes and ketones, that is due to the dipole-dipole interaction. Weak molecular association in aldehydes and ketones, that is due to the dipole-dipole interaction, and their boiling points are lower than those of alcohols of similar molecular masses due to the absence of intermolecular hydrogen bonding. So listen here, they are lower than the alcohols and they are higher than the corresponding hydrocarbons and ether, right? So 2 points we can remember, that is a carbonyl compound, that is the boiling point of the carbonyl compound. The boiling point of the carbonyl compound than is greater than two things. What is that? Hydrocarbons and ethers, right? Corresponding, even though the molecular mass is same, it is greater than the hydrocarbons and ethers, but it is lesser than the corresponding alcohols. Is lesser than the corresponding alcohols. What is the reason? Because in alcohols they have intermolecular hydrogen bonding. In alcohols they have intermolecular hydrogen bonding, but in aldehydes and ketones it is missing, so that they are having lesser boiling points than the alcohols, and they'll be having more boiling points than the corresponding hydrocarbons and the ethers, because of they'll be having dipole-dipole interactions. They'll be having dipole-dipole interaction. That may be the reason for this one. Then let us compare the molecular mass. N-butane is 58. So the boiling point is 273. N-butane is a hydrocarbon. Methoxyethane. So this is 281. This is an ether. So the boiling point is 60. And then propanol, this is an aldehyde, that is 322, the same almost equal molecular mass. Listen here, so here 58, 60 and here 58, so almost equal molecular mass, but see the difference in the boiling point. Here it is 273, 281, around 278, 270, 280, 270 to 280, but it is 322, right, which is almost 30 degrees Celsius higher than this, right? So this is because of the reason, due to the dipole-dipole interactions, it is having the higher boiling point than the corresponding hydrocarbon and corresponding ethers, right? Here this is a ketone, the same thing. Aldehydes and ketones will have the higher boiling points. And this is an alcohol, propane 1-ol, which is almost equal to the molecular mass of this 58, right? Here 58, 60, there is no much difference. But look at the boiling point here, this is 330 almost, this is 370. So 40 degrees Celsius. So this is due to the presence of intermolecular hydrogen bonding in alcohols. This is due to the intermolecular hydrogen bonding in alcohols, right? Is it clear? Again, um, the hydrocarbon and the ethers having less boiling point than the aldehyde, or the aldehyde will be having higher boiling point than the hydrocarbon and ether due to the dipole-dipole interactions and other reasons, and the aldehydes and ketones will have lesser boiling point than the alcohol due to the absence of intermolecular hydrogen bonding in aldehydes and ketones, but that will be present in the case of alcohols. Clear? Right. Again, the first member is a gas and second member is a liquid, and other members are liquids or solid. Then the lower members of carbonyl compounds, aldehydes and ketones like methanol, HCHO, and ethanol, CH3CHO, and propanol. So these are miscible with water. They are easily soluble in water in all proportions because they form hydrogen bond with water. So first three members or lower members, they can easily form the hydrogen bond. This is a carbonyl compound, right? This is a ketone, this is a ketone. So the oxygen of the keto group that makes the hydrogen bonding with the hydrogen of water molecule. So due to this hydrogen bonding, they are easily miscible with water. That is, what are they? The lower members are easily miscible with water. However, when the length of the alkyl chain increases, or the molecular mass increases, or the higher members cannot dissolve, or we can put it in a such a way that the solubility decreases, right? When there is an increase in the length of the alkyl chain, right? So that's the point you have to remember. That is, the solubility decreases with increase in the length of alkyl chain, right? So, in general, all aldehydes and ketones are fairly soluble in organic solvents. They are not completely soluble, fairly soluble in organic solvents like benzene, ether, methanol, chloroform. Like these are all organic solvents. In these organic solvents, it can be fairly soluble. The lower aldehydes have sharp and pungent odors. They'll be having the sharp and pungent odors. When the size of the molecule increases, when the size of the molecule increases, the odor becomes less pungent. The odor become less pungent and more fragrant. So both the cases are in aldehyde. That is, the pungent smell and the fragrant smell are the case of aldehyde. So when it is lower aldehyde, it will be pungent, more pungent. When it is higher aldehyde, it is less pungent and it will be more fragrant. Right? That is why more aldehydes and ketones, which are naturally occurring things, are used in the perfumes and other flavoring agents. They are used in the perfumes and other flavoring agents. So this is all about the pp of aldehydes and ketones. So we have to remember the first two members. First member is a gas, second member is a liquid. That is the two volatile liquid, and other members will be liquid or solid. And the BP of aldehydes and ketones, we compared it to the hydrocarbons, ethers, and alcohols. And regarding the solubility, when it is lower members are miscible and higher members are immiscible, fairly soluble. They are fairly soluble in organic solvents. And the smell, lower members will be having the pungent smell, higher members will be having the fragrance, right? That's it. Thank you, guys.